I'm free to give you a good number of very, very, very important secrets of state, which I show first time perhaps in this round. No, that's a joke. The numbers I put together and I will give you are quite publicly available, but nobody so far took care. So I will talk about costs and benefits and opportunities of Energiewende or energy turn, which happened since a couple of years in my home country, Germany. The whole energy turn is founded on two myths. One is the one of anthropogenic induced climate change. We spoke before in the forenoon about. I will not talk about that. And the second is a myth of limited availability of resources, which includes mostly fossil resources, but also atomic or nuclear resources. And my understanding of this, after studying thousands of studies, papers, newspapers, processes in the last 12 years, is that both myths are leading to deindustrialization of Germany. And I would like to show you why. In November 2010, our Chancellor, Ms. Merkel, gave the public 3 promises, and I took out the most important for our view now is the promise about energy. Third promise, we guarantee energy supplies. It should be reliable, affordable, and environmental friendly. For this we have presented as a first government in the world long-term energy plan. Knowing this reminds me to the last years of the GDR. Poland has a similar regime, which are happy if a 5-year plan would be fulfilled more or less without too much damage. And this plan she presents there as a 40-year plan because it runs until 2050. The reason for this long-term energy plan is that she is saying us the age of coal and oil comes to an end. Sink your voice down, comes to an end. And in a little speech to the German public, she said, but now starts the age of renewables. Great words. By 2050, 80% of electricity should come from renewable energy, a term which is impossible in itself, but let's argue about that. That would be a world record. The last part of the sentence is true. To understand what it means, what stands behind this promise, is the plan which is adopted now by the EU, how much the EU in total, but Germany in special, has to reduce its emission of technical emitted CO2. Right now, at the year 2000, we emitted about 800 million tons in various sectors, industry, households, traffic, and administration, and energy production. And we have said and agreed to reduce it by 80%. That means finally in 2050 we will be happy to show the world we are down to 166 million tons, which is about the volume which we use today for producing our food. I have no time to tell you what happens to all the sectors of creation of CO2 in the various areas, but I selected two of them. Number one is the power supply sector, which is the biggest, having 400 million tons annually, a little bit less. And the second is the heating of private and public buildings, which is about 135 at this time. And this should come down to 95 and 95 and 35, about that. These decarbonization areas are now regulated by a number of laws and will affect in total the households, heating, power supply production, fossil fuel traffic, as well as industrial production. I concentrate on heating and fossil fuel. Therefore, I selected the government acts or regulations, which is named Erneuerbare Energiengesetz, EEG, invented, and that's perhaps interesting for you, as a predecessor named Stromeinspeisegesetz, current feed-in law, by Ms. Merkel in 1992, when she was Minister of Environmental Affairs, and then blown up to this Erneuerbare Energiengesetz, Renewable Energy Act, in 2001 by the Green-Red government under the Green Minister for Environmental Affairs, Jürgen Trittin. And it's followed by another act, which is called ENEF, Energieeinspeiseverordnung, or translated Energy Savings Act, which is directed to the private and public buildings. And recently they added a new EEG-W for heat, for warm, Erneuerbare Energiengesetz, Wärme, Renewable Energy Heating Act. This forces the private and public owners of buildings, in case they want to replace an old heating system for more than so and so many years, to build in by law renewable energy supplies rather than fossil heated ovens or furnaces or what have you. The purpose of the EEG is defined in the preamble. The purpose of this bill is in the interest of climate and environmental protection. Therefore, we can just put in climate protection. Environmental has nothing to do with it. In order to reduce the economic cost of energy supply, to reduce it, and to allow integration by long-term external effects to conserve fossil energy resources. But it finally goes and come up to be a wonderful tool to make electricity a luxury good, what Spiegel, the major magazine in Germany, named electric currency becomes a luxury goods for the most of us. And why is it that way? In case you are not so familiar, and you all are, with the flaws of the renewable energies in terms of physical processes and behaviors, I put together some ideas and some examples why the effect of changing to renewable is very, very ineffective, and vice versa. Engineers can go around this ineffectiveness, but becomes very expensive. I have here a picture of before the largest photovoltaic area in my home area, Brandenburg, which is a province of Germany. It covers 182 hectares, that means 1.82 square kilometers on area. It was erected in Brandenburg, which has normally the sunlight of Alaska, this amount of sunlight, I don't know exactly of southern Alaska or northern Alaska, but in the mean of Alaska, and was until this the first biggest in Europe, and now it's the second biggest because we just opened another one which is much bigger, a little bit bigger. This plant delivers an amount of energy of approximately 60 gigawatt hours. Don't be disturbed by the numbers. Applying a usable factor of 8%. That means 8% of all hours of the year, which is numbering to 8,760, it delivers rated energy. In order to deliver, but only by numbers, only by calculated numbers, not in reality, the same amount of energy like a coal plant of 750 megawatts, one need 100 times a plant like this. It would cover 180 kilometers squared and will cost 11 billion euros. When I say billion, I mean the American billion, not the German billion, so with 9 zeros after the 11. But that is not enough, because also in Germany, also in my homeland Brandenburg, the sun resists to shine at night, and the evening, in the morning perhaps also quite a little. And therefore we need a buffering plant, which costs another 0.8 billion. So this together then ranks up to 13 times the investment in total what we have been able to deliver with one single coal-fired or oil-fired plant before. And due to the fact that it is heavily subsidized and the investors are not stupid, they get about, at this stage, 8 times the price for a kilowatt hour than the owners of a coal-fired plant will get, 8 times more. That's good business for them. Therefore, they intend to erect another plant, or that's just happened. The biggest PV station is in Templin nearby, about 50 kilometers. And this turns out to be even 17 times more expensive than a standard coal, highly cleaned power plant, which could be erected nearby. What I want to show you is that the energy density of sun, and I will continue with other examples, is much, much less than any other mean of energy production which you use so far: coal, oil, gas, atomic power. You can easily spend your holidays in Spain at the beach, put yourself without clothes or with just a little into the sun, and what you get is sometimes a sun-tanned, I don't know the right name in English, Sonnenbrand, what is it? Sunburn. Sunburn, thank you. And that's it. But in case you want to check out how dense the energy is in an oven fired by coal, and you put your hand in, that will not last very long, not even seconds. So the energy density is much, much lower in sun, and that's the reason why we have such huge amount of area and cost. The magic tool to overcome the weakness of photovoltaic is the offshore wind power production. Here is an example which Germany erects in the Baltic Sea, named Baltic 1. I phoned the owner, which is a big power supply company in southern Germany, and this image shows the plant with 21 wind turbines. Miss Merkel was proud to open it, to cut the band and say, now start, and it starts and it runs very well. Rated power was, or is, 48 megawatts. they have a usability degree of 40% compared with the 8% of the sun. 40% is really high. It costs 200 million euros, and it covers an area of 7 kilometers squared. To replace by numbers only a power supply factor of a power station like Brockdorf, which is in Hamburg, 1,400 megawatt on rated power, you need 66 of this Baltic 1 plants with 1,400 wind power stations about, cost 13.2 billion euros. And in addition, you need 1 times a power plant like the existing Brockdorf, because even on Baltic Sea, wind is not blowing all times, and we depend on highs and lows from the weather, whether we create the electricity we need. So we have to add this, which is double as much or triple as much as the other one. We end up to 15.8 billion. This Brockdorf power station supplies Hamburg, the city of Hamburg, and to replace it, we have to cover half the city of Hamburg in order to establish it. So in total, it's not 13 and not 17 times more expensive, just 6 times more expensive than conventional. But it delivers nothing different. It delivers just the same, but it's 6 times more expensive than conventional. That is the reason why even every approach to reduce the cost of renewable energy is limited to the low energy density, and I have not spoken so far about the volatility, which is the other natural law which allows us to deliver current whenever we need it, because we cannot store the electricity. The area which is covered by such technology, I took out of a British newspaper. They decided to buy 10 atomic power plants, nuclear power plants in the United Kingdom. The first one is rather expensive. It will be erected at Hinkley Point. I don't know where it is, in the north of England, I guess. And it covers 1.74 kilometers squared. By the way, this will be built to 90% by Chinese companies, and 10% has Areva, the French company, the honor to deliver the shovels and the workers to prepare the ground and perhaps to spend some money for it. Even now, the British government has not enough money to pay it by themselves. So 1.74 kilometers squared. Having the same rated energy produced by solar farms, you need 526 kilometers squared, covering, that is 300 times the area. And if you use it by onshore wind farms, you need 1,000 kilometers squared, that is 580 times. Now people say, oh, forget all this, we have biomass. So biomass is even more worse in energy density and requires about 3 times the area of the wind farms, where you can, of course, seed corn and harvest it and put it together and then make energy out of it. So once we want to fulfill our plans in Germany with biomass too, which is storable, you can produce the energy as soon as you want, you need about 3 times the area in Germany where agriculture is possible. The other problem of renewable energy is the volatility and the non-predictability when it is available. So you need storage. The biggest German storage is a, I don't know the right English name, pump storage unit established in the former GDR in the area of Thüringen. it is this wonderful area where you use the electricity which is overdue, and then you pump up the ground water or the water in a lake up to hill, and when you need it you open the valves and let the turbines run and produce the current you have. That is a very good and old known technology, and it has a efficiency of about 75 to 80%. So 100% energy put in, 75 to 80 comes out. The loss is about 20 to 25%. This is the biggest in Germany, and this is one of the biggest in Europe. It delivers 1 gigawatt for 6 hours and it's empty. It had 30 years of planning, 11 years of construction time. It cost 600 million euros. The rated power is 1 gigawatt for the duration of 6 hours, means 6 gigawatt hours, or because we need this unit later on, 0.006 terawatt hours. In order to overcome 10 days without wind and sun, as the plan says, in 40 years we want to have 80% renewable, you need 2,199 units of it, which will cost about 1.3 billion euros. Now people say, oh, we are not depending on Germans' topology, we go to Norway, but the Norwegian people are not crazy. They say, number one, our water power supplies are frozen during winter quite often. Number two, that's fresh water and not salt water, we cannot make it. And number three, we are not thinking in the nightmare to deliver by our wonderful fjords and valleys and mountains from the energy to Germany. Therefore, the people, the engineers, have a good idea that we have wind power and photovoltaic power enough, which we cannot feed in the grid. So let us make gas out of it by known physical processes. So the newest type is wind to gas or power to gas. And here is a chain of the production step you need to have created current, electricity by whatever means. Then you apply it to electrolytical process, water. You separate water into hydrogen and oxygen. Then you use the hydrogen and mix it with carbon dioxide to create methane, and then you feed it into the gas net, and then you burn it again by a gas turbine to create electricity. So you have in 5 steps to make from energy, electric energy, now electric energy again. The final efficiency of this process lies anywhere between 15 to 35%. That means when you put in 100% of electricity, you get out 15 to 35. It will come out 2022 because it's an intermittent process and others problems are arising there that you will not be able to go to the 35% which is here. What does it mean to the cost? Here is a comparison. Here we have the pump storage facilities as known since some 100 years ago about. And at former times, before the Energiewende start, the price per kilowatt hour was about 8 cents per kilowatt hour. Now it rises because we don't have the current cheap enough to feed it. And the power to gas price is here about 75 cents per kilowatt hour, but it comes near to 230 because of the differences in efficiency during the whole process of creating hydrogen and then making electricity out of it. So anywhere between 75, 100, 150, 230 cents per kilowatt hour will be the result. Here I have 3 curves. The blue one is the annual payment of the grid companies to the owner of renewable systems. This is 100,000 million, so 100 billion. This is 200,000 million, so 200 billion, and so forth. And here at 2013, we have paid 23 billion euros, we, the consumers, to the owners of the renewable energy. That means 80 million Germans have paid to about 800,000 people this amount of money. And the green curve shows the sum of this payment up so far, which piles up to 122 billion already paid for this idea of feeding our electricity or creating our electricity by renewables. But this law, which is the most important export good from the government, 46 nations have adapted to it. It forces us as the consumers to pay this amount for the owner 20 years long. The idea was to ensure investment security, and every company owner says, oh, wonderful, here I have an investment security. Where else in the market I have investment security for such a long time? Nowhere, but here we have it, 20 years guaranteed. So this piles up to a debt of 330 billion euros. So we owe the owners of the renewable energies already 330 billion euros, which we have to pay for the next 20 years. And since this is a very good business, a lot of power is invested to avoid any change. And if you write it on, or you calculate further, in 2022, okay, we have to pay further 700 billion euros. We have already paid 496, and in this year it piles up to 600 billion euros. In total, it's about 1.2 trillion euros for these people. That is the result in cost and price and euro just for the EEG. I told you that we have also the ENEF, which is asking the owners of the buildings to insulate their buildings and to build in renewable ovens and these type of things. So the basic figures are 40 million households, from which we have 19 million units, that means houses or flats, and 3 million public-owned units. They share of the total 35%, and they are aimed to reduce their CO2 production by 76%, down to 32 million. I make it faster. That is especially for the heating system. The media shows that after investing the money needed for that, forced by this law, we will have such wonderful buildings, very nice, looks beautiful. What we often get after a while is this: about 50% of all lawsuits in Germany are about struggles between tenant and owners, is this black and green mold. After a while the building are looking that or like that. That's what we get, not in all cases, but in very quite a lot of cases. And here I have the same type of curves, shows the development of this. The blue is the public and the green is the total. We see here we have paid already 300 billion euros for this, and now it's speeded up because government forces us to be faster, 2% annually. This comes up to this value. Here we have today already accumulated 570 billion euros spent, and this goes up in 2023 to 1.2 trillion. A number of independent studies shows that the return on investment for this investment is not nil, not +1, not +2 or +3%. It's in average -3%. So you not will only lose money in spending it for this insulation and other means, but you have to pay annually even more to keep it alive, to keep it work. Here again, 3 trillion in total, and you have increased maintenance cost. If you have a normal house, you have to spend 7 to 8 euros annually per square meter for the facade, and by applying the INEF law, you have 16.2 euros. So the proprietor, the owner, is forced to spend all this money, and the law says you can transfer this money to the tenant, and he either can get out or has to pay it. In 10 years you can apply about 10% of the invested money. What I haven't tackled so far is what happens to the industry. The industry is the backbone of our wealth, and the industrial production is heavily affected. I don't know whether you are aware, but Germany is one of the only states in Europe which has still a very long and working production chain of basic material production to highly complicated windmills, cars, or what have you. So this production chain is measured by different economic studies, and it shows the production of various countries. As higher the degree is, as more things are produced in this country. China is with 34% on top, followed by Korea, Southern Korea, 27.9% of the total gross product is by industry, and only if the industrial chain is complete, so from basics to most complicated. And Germany is about here with 23%. When you add the outsourced services like IT or others, you come up to about 30%. In comparison, the two of the United States are about 11%. So these states are depending very heavily on servicing industries rather than on production industries. This will change in the US right now, as we know here, because of the cheap energy you can supply to the industry. About 1 kilowatt hour is 1/3 of what we pay there in the United States compared with us. Germany has the highest prices for electricity, Czechia a little bit more, and therefore the move of the industry has already begun. That is I have not to read it, you can read it yourself. That is the saying of the president of the BDE, which is the biggest industrial group, which talks with politics to make happen that we are doing in law and in others the things the industry wants. Grillo is the president of it, and he said energy-intensive industry has reached the limits of its resilience. They will go off, they will go out of this country, and it starts before, because these companies already don't invest anymore, even not in new buildings, new production plants and new process lines, but also say we do not invest in repair and maintenance. So let it fade out, aluminium, cement, copper, and what have you. In this industry we have about 1 million jobs, and they are all due to be lost. And it's unlikely that in Germany again a new steel plant is built, a large chemical plant or plant for carbon filter fibers will be erected. And what happens are, and now I have some German newspaper headlines from the last few months, the silent farewell of industry. Germany suffers deindustrialization. The intended leave out of Europe begins. We are at the limit. Germany is threatened by deindustrialization. BASF warns for exodus of industry. BASF is the biggest chemical plant in the world. And the others say, okay, the Energiewende shouldn't cost any jobs, but of course it will do. So the reason for doing all this is named the big transformation we have heard yesterday a little bit about. And to bring this to the public in a more understandable way, the originators of this transformation, Mr. Schellenhuber and a lot of other people, produced a comic for bringing it to the kids. I just show this example. So what I would like to tell is, with the idea of big transformation down to decarbonized industry and economics, we are facing with a real threat to our wealth, which have just started 3 years ago. But the idea is to really come down with CO2. And what does it bring? And here I have again the graph of the plan. What does it bring to the climate? That is what finally comes out. And we have calculated it by the rules of the IPCC, which is a fairly simple calculation. What is Germany's part to reducing world temperature increase? From 830 million tons to 166 brings more or less 0.004 degrees centigrade. But only if you apply the IPCC special physical laws, which have built in a water vapor amplification of 3. If you don't apply it, it's even less than that. And if you apply this for the whole EU, which follows the same scheme, you come perhaps to 1/100th of a degree of centigrade. Now, when I mentioned this yesterday to the chairman of the lectures, that this might not be a good result, having no visible, no detectable, no seeable influence to world's temperature, whatever this is. He said, yes, but you should not forget the opportunities. And therefore I said, okay, opportunities, if they're might there, I will have a look to them. But I looked as much as I could, and I discovered none. There is no opportunity which can be chosen except that we make 80 million people poor to make about 800,000 people rich. That is, of course, for the 800,000 a huge opportunity, and therefore I can only state only pain but no gain for all of us, except for very few. And with this I will end my lecture and let you deeply depressed, I hope, back. And I am happy to answer the one or the other questions. Thank you very much.